Hey everybody, it's Mr. Campbell here with Mathematical Anarchy, and we're here today talking about combining functions using sums and differences. For our first example, we're going to consider a household that has multiple income earners. Each person's earnings is a function of time, and we can see that because for any given week, each earner only has one amount of money associated with them. So one of the things that we might naturally consider is how much money does the household make as a total? And we could do that by adding the values of each of these earners together. For the first week, we can add 500, 362, and 120 together to get 982. We could do the same thing for each week, adding the value of each of the three functions together to fill in our table. So there's a lot of things going on here. One thing we might notice is we've created a new function. Each week is now associated with only one total amount of money earned for the household. So it's a function. We should also notice that the domain is the same. We have each of the 8 weeks for each earner, and that's the same each of the 8 weeks for the total. So for all 4 functions, the domain is the same. If we think about the range of our total, we just put the values in order from least to greatest, and it tells us that the least amount of money earned was $890 that happened in the 8th week, and the most amount of money earned was $1,040, which happened in the 7th week. Thinking about function notation, we had 3 functions to begin with, f, g, and h. So f plus g plus h of x is equal to f of x plus g of x plus h of x. Using the variables that would correspond with each of these, the total is equal to earner 1 plus earner 2 plus earner 3. Again, they're all functions of time. A business has 2 investors, each investment being a function of time. So like the last example, something to consider might be, what is the total investment for the business? Which sounds a lot like addition. So with our function notation, we would have f plus g of x, or f of x plus g of x. Using the notation we have here, we could use c as the combined investment, and we could substitute the values we have, 42,000 plus 500t for the first investor, and 35,000 plus 1,000t for the second investor. So that gives us a combined investment as a function of time of 77,000 plus 1,500t. Again, we've created a new function by adding together these other 2 functions. What makes it work is that both functions were investments, and they were also functions of time. For our last example, we're going to take a look at the difference in the number of deaths this year, in our current year, compared to the average of the 5 years prior. So the excess number of deaths is going to be the current number of deaths minus the average number of deaths. So if we calculate that for January, 5,687 minus 5,680 gives us 7. So there were 7 deaths in excess this year compared to the average of the 5 years before. We could do the same things for February, March, April, May, June, and July. But we stop at July because the domain of our current year only goes from January to July. So we have no values to compare to the average. So we're going to stop there. We're going to restrict the domain, and we're not even going to worry about August through December, which means we also don't need the output values for the average function that correspond with those months. Again, thinking about this, we've created a new function. For each month, there is now a single number of deaths in excess of the average. Listing our range, right, our values from least to greatest, we can see the month with the fewest excess deaths had 7, which was January, and the most excess deaths occurred at 3,022 in July. If we think about giving variables and thinking about function notation, we could just use f minus g of x equals f of x minus g of x, or we could give variables c of m to our current year as a function of the month, and a of m, the average, as a function of the month, and we can refer to the excess as e of m, and can replace our function notation with that. Excess is equal to the current minus the average. E of m is equal to c of m minus a of m. So in this video, we've taken a look at sums and differences of functions, and we've come to the conclusion that all we have to do is add or subtract the corresponding values or equations that we have. The key is that the domains should be the same and correspond, and we might need to restrict the domain when necessary. So now go out and try the practice and be ready to ask any questions you have next class. Good luck.